area. So most of the area formulas you should be fairly well familiar with. So if I have a square, hopefully you'll know that it's just one side times the other. And in the case of a square, the sides are all the same. So it's basically your length times your length, or your length squared. And don't forget to quote your answer in units squared. So if it was being measured in centimetres, it would be centimetres to the power of 2, or if you're measuring it in metres, it would be metres to the power of 2. So don't forget those little things. If it's a rectangle, then you know it's the length times the width. And again, don't forget to quote your answer in units to the power of 2. Triangles are half base times height. Now, don't get too confused with the triangles. Sometimes they'll look like this. Your base can be any of the sides. It actually doesn't matter which side you call the base, but your height must come at a 90-degree angle from the base. So in this case, I'll be using my base and my height as shown here. If I have a triangle that's sort of pushed over like this second one here, then you've got to remember that the height actually isn't inside the triangle, but it's measured on the outside, basically so that it comes at a 90-degree angle to the base still. So my height will be measured outside here, and my base is just that measurement across the bottom of the triangle there. So it doesn't matter what it looks like, but the measurement's the same. It's half of base times height, which we traditionally have shown like this. You should also be comfortable seeing it like I've put it in the second box here. It means exactly the same, where I've gone base times half and then divided it by 2. So be comfortable with either of those. The next shape is what we call a parallelogram. And we know this because it basically looks like a rectangle pushed over. And what we're looking for here to know it's a parallelogram is that we have 2 pairs of parallel sides. So these little markers here don't mean necessarily that the sides are the same length, but they mean that they run parallel. So I've got the double arrows here show that those 2 sides are the same. And then I've got a single arrow on these 2 sides which show that those 2 are also parallel. Now, when you get the area of a parallelogram, it's the base times the height. Now, I'm going to change colours again here. The height, again, has to come from a 90 degrees from the bottom. Sometimes they'll try and trick you, and they'll give you one of these sloping side measurements and not the height. You can't use that to calculate the area. So it must be this height. If you visualised me chopping off this triangle at the end and sort of transferring it to the other side, what you would see is that it would then give me a rectangle with that base and height dimensions. So that's why it works, if that helps you to understand. But don't get fooled and don't use those little side measurements. Now, let's take off those extra ones. The other one that's really important is a trapezium. Now, these appear quite a lot. I'm just going to write that down. So it's a trapezium. These appear quite a lot in the exams for ATAR students. And often people don't even identify them, or they don't recognise them. What people want to do is they see a shape and they treat it as a composite shape, and they want to turn it into a rectangle and a triangle, or in this case a rectangle and 2 triangles. Certainly you can do that, but at a mark a minute you need to be doing your questions in the most efficient way that you can. So what you're looking for in a trapezium, first look out for them. Then what you're looking for is the pair of parallel sides, and those are the ones that we are going to label as A and B for our formula. And our formula is basically that the area is equal to A plus B divided by 2, and then timesing it by our height. And the height, like all of these formulas, must come at a 90-degree angle from one of those A or B measurements. So in the case of that first shape, that's fairly obvious because it's sort of given here. But if you have a shape like the second one, and they're both trapeziums, that height must be measured internally, dropping down to a 90 degrees to one of those A or B measurements. And then you're good to go. There was another thought I had, and it's just left me, so I'll see how we go as we go through the questions. But basically what you're looking for when you look for the questions, look for your parallel sides. They're the ones that you're going to put in a bracket at the top. Don't forget to use a bracket, because if you use your calculator and you don't show your working sort of 2-dimensionally here, then basically what's going to happen is you'll get sort of a tragic BIMDAS error going on. So the brackets will just help you to make sure you do that calculation first before you divide it into 2. And that was the thought I was having before. The reason, just so that you understand the maths, it's better to understand than to rote learn. The reason that this works, the a plus b divided by 2, is effectively we're turning this into 2 triangles. So when we do that a plus b, you can see that basically the a and the b are the bases of the 2 triangles. The height would be the same for each of the triangles, and therefore you're basically just combining 2 triangles into the one dimension there. As long as you remember the formula, you're good to go. So let's have a go at a few of these questions. So these are all, well, not all of them, they're mostly what we call composite shapes, so we've got more than one shape going on. So in the first one, that's relatively self-explanatory. I've got the area of a square, which will just be 18 times 18, plus the area of the triangle on the top. So let's do this one to the side of it, shall we? So if I was doing this one, my area would be equal to 18 times 18. That's my square part of the shape. Plus, I've also got the triangle. And for a triangle, it's a half times the base times the height. Now my base here, we can see from this marker that my base is the same as that other 18 side with the 18. So half times 18 times my height, which is 7. And altogether for this shape, I'd wind up with an area of 387, and that was being measured in centimetres, so it would be centimetres squared. Don't forget to put those units in because that's very important. Okay, if I was to do the next shape, you can see here that I can turn this into 2 rectangles, or a rectangle and a square rather. Now I could divide it this way into a rectangle and a square, or I can divide it this way, and it makes no difference, so please yourself. What we can see is that the sides are the same, and whilst they haven't given us the side, across to the left, and they haven't given us the top measurement, we can see that basically, and I'll change colours here, that if I got these 2 sides and collapse them down to the end there, you can see the measurements are the same. So this top bit is obviously made up of 2 measurements of 7, so I'm going to have a measurement of 14 centimetres altogether going this way. And by the same logic, I've got 14 centimetres going this way, because again, I'll just change colours again. If you looked at these 2 sides, if you sort of brought them down to the side there, it's the same measurement. So to get the area, I'm going to basically be going, the area of one rectangle would be equal to 14 times my 7, plus I've got the little square, which will be 7 times 7. And so altogether, my area for that shape would be 147 centimetres squared. Okay, here we have a trapezium and a triangle, and this question asked us to find the shaded area. So in this case, we needed to get the area of the trapezium and then subtract the area of the triangle. So the area of the trapezium, again, when we do area, what we do there is my a plus b, which is my 2 parallel sides, divided by 2, times that by the height of the trapezium, which must come off a 90 degree angle. And then I'm going to take away the triangle, and the triangle area is a half of my base times my height. So if I substitute into here, what you can see is that my parallel sides, and I'm looking for those parallel markers, are 10 and 7. So when I substitute into here, it's my 10 plus 7, divide that by 2, timesing it by my height, which is this measurement. You can see that's coming, they haven't shown a 90, but we can, or they have at the top. So we know that that's the height, so I'm timesing that by 8. This all together will give me the area of the trapezium, and then I would need to subtract my triangle, which is a half, times my base, which is 3, and my height, which is 2. And again, it actually doesn't matter which order you do that in the triangle. It doesn't matter which one you call the base, which one you call the height. The only thing that does matter is that those 2 measurements must make a 90 degree angle with each other, so that your height is in fact taken from a 90 degree angle. In this case, once I've processed all of that, I would have wound up with an area of 65 centimetres squared. Centimetres squared. Lovely. Okay, I might just take all that highlighting away for you so you can see it all. Sorry, no, I've just messed that one up, so put that back on. It's 10 plus 7. Okay. Sorry, this is all disappeared times my height, which was 8. Subtracted more than I wanted to there. Okay, the triangle, again, it doesn't matter that this triangle is kind of pushed over, but when you do it, you're going to have the base and the height. Now, what they have done, which was a little bit tricky on this one, is that what they've given you here is the measurement. I'll just change this colour because I don't like it. They've given you this measurement here of 6, but what they actually haven't told you is what the base of the triangle is over here. So to calculate this, you're going to need to use Pythagoras, and we find that Pythagoras kind of pops up all the time in maths. They like to do that as a favourite sort of trick question. So what we're going to need to do is to use Pythagoras. Pythagoras only works on a 90-degree triangle, so the triangle we're going to use is actually this full triangle that I've now highlighted in blue, and I'll use a blue pen so that you can keep track of what I'm doing. So to get what I'm going to call this x right along here, so what I'll be calculating, as I say, because I can only use the 90 degree, will be there. It would be one of the short sides in the Pythagorean theorem, because the long side is always this hypotenuse, which here is 17. So to find x, it's going to be equal to the square root of my long side squared, so my 17 squared, take away my other short side squared, which is 8 squared. That's going to provide me with my whole side, and so that would give me an answer of 15 centimetres. Now, from that 15 centimetres to find the base, so we'll put a B in there for the base. To find the base would be equal to that 15, take away the 6 that they've provided me over here. And so all up, I've got a base of 9 centimetres. So once I now know that, I can fill that in on my diagram. And now I can get the area of the triangle, which is going to be equal to a half times my base, which is my 9, times my height, which is the 8. And again, that height has to come, from that vertical measurement of the 90 degrees. So I would pop all that through, and that would give me an area of 36 centimetres squared for that triangle. The next shape is basically just a rectangle and a full circle made up. So we've got the two half circles, but together they'll make a full one. So I've got a rectangle here. So my area for that one would just be equal to my 50 times my 100. So 5 times 1 is 5, and then I've ignored the 3 zeros. If I put them back on, that gives me an area of 500 metres squared for the rectangle. And then for the circle, there's for the rectangle, and then for the circle I would have an area of pi r squared. Now, they haven't given you r in this question, they've given you the diameter, so what you need to remember is that the radius will be half of that, which in this case would be half of 50 is 25, so it'd be 25 metres. So for your circle, you're going to go pi times 25 squared, and that will give you, where am I? Sorry, I calculated that somewhere. So for my circle, I get basically 1,963.495. And for the moment, I'm just going to say to you, leave all these decimals here, and we always deal with those right at the end. And then I'm going to add my rectangle to that, so adding the 5,000. Then altogether I would have a total area which is equal to my 5,000 plus the 1963.495. So altogether I've got an area of 6,963.495. Now this was being measured in metres squared, and so basically my decimals therefore mean centimetres, so it would make sense to go to 2 decimal places. If I was going to stop at the second decimal though, my third number is what I checked to round, and because it's 5 or more I would need to bump it up. Now because that's a 9, I'm actually going to take that to a 50, so 6,963.5 would be my final answer here in metres squared. Okay, and it looks like I missed a circle one. Circle's just going to be your pi r squared for the outside circle, take away the inside circle. So my area here would be equal to pi times my radius. Now don't forget they haven't given you the radius, so you need to halve each of these measurements to get the radius. So I've got 5 for the outer one, 2 for the inside one. So pi times 5 squared would be the outside circle. Then I'm going to take away pi times my 2 squared to get the inside circle, and that would give you a final answer in this case of 65.97 centimetres squared. Okay, I might pause there because the videos get long, and then I'll do the next ones.